All right. All right. There we go. Now we're back with excellent. OBS is staying under the 6,000. Okay. Cool. Well, I'm glad we figured that out. Cool. All right. So yesterday I was doing a LeetCode problem. This problem 944, which was pretty easy, and we came up with a solution that's like everybody else has that, but there was like one thing I started to wonder today, and that was like this would be a lot faster if instead of having to loop like this, we could like process more than one part of the string at a time. So that made me curious if we could use SIMD or single instruction multiple data stuff. I don't know if LeetCode has that. But there was another thing we were looking at yesterday, and that was I was trying to show debugging some code when it had been compiled with optimization, and it wasn't working. Debugging wasn't working. So what I figured out was like we can compile it with the optimization flag, and we can use Z7 or we can still use ZI. Either one of those works. Um, and then the thing is that if I place a breakpoint up here in the function, that's not going to get hit. Yeah, see, no breakpoint was hit. So, okay. However, if I place a breakpoint like here, that does get hit. So, and then if I like step through, and then typically, like, when there's a function here, you can hit F11 to step into instead of step over. But if I hit F11, it just steps over anyway. So that tells me like that the optimization, what it did is it stripped away this whole function. It inlined the code. Um, so this function is when you compile the code with optimization, this function doesn't even get called. All that code gets inlined. So that's why last night I couldn't set a breakpoint in here. Anyway, so I thought that was something cool to have figured out. And it also kind of means that, like, so then the follow-up to that I looked up is like, so on LeetCode, when you are using C++, well, like, what is it? How is it compiling that? And according to their documentation on support LeetCode, they're passing in the O2 level optimization, which C is using GCC Clang. Okay, so C++ is compiled with Clang, so we can actually go to what did it say? It was so Clang 11. So we can go here and do. I was doing MSVC, but we can pick Clang, Clang, Clang. Oh geez, what is all this? What is all of this? I just want C++. There we go. 11, right here. Boom. So that's the same as LeetCode, and then we can do. So that should compile it the way LeetCode is compiling it. Okay. Which still seems like it's compiling that. Let's go see. The only thing is on Clang, Clang or Clang, I don't know what the O2 flag does. So let's just let's just close the loop on this. Oh, geez. Okay, so O2, moderate level of optimization. All right. So that's not necessarily the most level of optimization. Like, let's do... I wonder if we do like O3. I guess what I was looking for was to see that it didn't create this section here. It didn't create the function. But, you know, I don't know what it really means when a compiler inlines stuff. So I think the main takeaway is I know just enough. I know just enough to look in here and sort of make sense of what's going on. But I, you know, need to work on understanding what I'm looking at in this disassembly view. All right. So with that being said, what I wanted to double check tonight was can I bring SIMD in here? So like one thing I don't like about LeetCode here is it's not showing you what is included. So like obviously since they're using vector and string, those are included, and since you're not having to type standard in front of everything, that also means that they've already done the using namespace. So there's some things they're doing for you. That's the point here. And it would be nice if it would be nice if they told you what that was. Like, not told you what that was. It'd be nice if they gave you a view where it showed you what all was being included. That's what I'm trying to say. No. All right. So, and I know like there's this thing that I saw on Stack Overflow a long time ago or a while back about processing. This guy was, or this dev was using SIMD to convert string to write a to-upper function. So I know that you can do string manipulation stuff with SIMD. I just don't know how to do it myself. So I don't know how to do it myself, and I don't know if LeetCode will even let you use it. I don't know why they wouldn't. I just don't know if they do. Let's see if we do run here for this. Let's see if just adding that header breaks anything. It did not. Okay. Now let's see if I can figure out how to even use this SIMD stuff. Is there a way to... Okay. I'm going to do this. I'm going to put that there. And I'm going to take this. There we go. All right. Cuckoo, 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 cuckoo. Oh. I forgot to mute my desktop audio, so I'm going to do that now. All right. So let's see. First off, I don't know what this all is. I am not expecting to get very far with this. I'm not expecting to get very far at all. I just want to see, like, can I even load a string into it? All right. Okay, so this dev notes something interesting that I didn't think about. And that is he has a note about scalar until the source pointer is aligned, which I believe, yeah, he makes the note here. Well, not strings. SIMD things need to be 16 byte aligned. Which, if you're asking me for a definition of what 16 byte aligned means at this moment, I don't have 100% locked in. I would say, like, the address is like some multiple of 16. That makes sense. Which I think would mean, yeah, some address of 16, some multiple of 16. Which I think would mean it has like fours. The first 4 bytes would be zeros, if I'm thinking about that correctly. But anyway, well, since we're doing this, trying to be educational, what is byte alignment? Structures. Blah 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 blah. Data structure alignment. Wikipedia. Stack Overflow. I dropped my pen. Pen retrieval. Yeah, so an object that is 8 bytes aligned is stored at a memory address that is a multiple of 8. So if we were to try that to 16 byte, then it's a multiple of 16. Aligned is that faster because, I mean, for SIMD, the reason it would need to be 16 byte aligned is because I believe that's how it, a SIMD is 128 bytes, so, or 128 bits. I always get confused on these things. 128, wait, 120 divided by 16 is 8. I don't think it can fit 8 things into one SIMD register. I think it can fit 4, if I understand correctly. But 4 would be 60. It's 32. All right. Well, there's some things here that I don't understand, except for I know that SIMD needs things to be 16 byte aligned, and I know that that is somehow related to like the data, how much data can fit into a SIMD register. Which I don't even know if it's right to say SIMD register. The registers that SIMD functions use. All right. Just trying to be clear about like things I semi-know versus things I just flat out don't know. So like I don't think SIMD uses certain registers is what I'm trying to say. All right. So I think the trick here is that we would have to do something if we wanted to do this, we'd have to do something similar of making sure our data is 16 byte line, which I don't know if we actually might get weird for us since we're in the LeetCode problem. We're getting reference to a vector, but We're getting strings, not car strings. So how is he doing? How is he doing the 16-byte alignment check? So 0. So FFF. This is all ones and so this right here is the alignment check. Let's see if I can think about why. So bloop bloop bloop. Here we go. Draw. Wait while my tablet comes up here. All right. So F is 1 1 1 1, right? And we're doing and source src is a pointer, so it's just an integer. So I think it would, it's going to be, I think this is, yeah, it's going to be something like it's an integer, so it's something like 0x, ff. This ff isn't important. It's just that it's two of these. An integer is two of these, if I remember correctly. Right? Is that right? Or maybe it's four of those. Shoot. I'm getting myself confused of things I know and things I don't know. But either way, let's pretend like we sort of know. So I do know that 0f. Do I know? Yeah, I know that. Okay. And then you have your source, which is just an integer because they haven't dereferenced it. It's dereferenced right there. So it's just an integer. And so what I'm thinking is, since I said the thing of like it has to be 16-byte align, which means the address has to be a multiple of 16. So if we do 0 and some address, there's some aspect of this that I don't know. Because what I'm struggling with is this expression has to be true for this while loop to continue. So something about this being true means that it's not aligned yet. And that's just a bitwise. Oh, I get it. This is because this is a bitwise and, which I knew it was a bitwise and, I just didn't totally. But yeah, so what's going to happen is the bitwise and is going to run, and it's going to actually be non-zero, right? Like it's going to be. It's kind of like a mask. I mean, I've written this like 3 times. I don't know why I have to keep doing that. Right? It's going to be like if you're doing why do I have to keep doing this? Sorry. I'm kind of like obsessing here. If you do 1 1 1 1 and something that Yeah. So like, let's say it's this. Doot, 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 right? That's going to come back as, that's going to come back as uh, true, true. Oh, yeah, so you're just going to get this back, right? That's the way the and mask works. False, true, right? And so that's not 0, and so it's true. It evaluates the true in this, like if true is anything that's not 0, okay? That's what I'm trying to say. And so then if we do 1, 1, 1, 1, and all of this is 0, right? Then we're going to get all zeros. That's going to be false. And if the last, so if the last four zeros, of your address are 0, that means it's 16-byte aligned. And the easy way to do that is 2 to the 0, 1, 2, or 1, is it 2? What, 2 to the 3 is 8? So, yeah, 2 to the 4th. So 1, 1, 2, 3, 4. 2 to the 4 zeros equals 16. Right. So there must be something in C++, but the thing is that I know this pointer is an integer 2 bytes or 4 bytes. I think an integer is 4 bytes, right? Yeah, an integer is 4 bytes. 4 bytes. And a byte is 8 bits, right? So all I'm drilling into here is like this AND operator must work on the low bits, right? Because your source integer or your source pointer there, your memory address, which is an integer, it's like F F F F, and we're doing like F and that's a terrible ampersand and A B C 0. Right, so this operator must work on the low bits, unless, of course, you were to pass F, or maybe 0F is kind of like an implicit all, which we could check that with a debugger if we wanted to. Kind of curious about that. Let's see in C++. That's not what I wanted. Let's see if this has what we want. Bitwise and. Hmm. I was just looking to see if it like clarifies, what the behavior is. Oh, interesting. So mask. Yeah, I wonder if like you even have to specify these. Which we could check. Why don't we go check? We have the technology, right? We have the technology. I should just know these things, but since I don't, I don't. I don't think I have. Mm. Let's just see what that is. I don't think I have. Oh, okay. Let's compile this without optimizations. Hexamer. Yeah. So here I just switched in. I switched in my watch window. I switched between. You can switch between hexadecimal display and decimal display. So with hexadecimal, you can see the defaults to all the other parts, all the other words. Are those words? No. All the other. It's not a byte, right? Uint short, unsigned in. Why am I getting so confused right now? Can I type? Okay, I can't do that here. Okay. I don't know why I'm getting super tripped up about the size of types right now. Okay. So if that's 32-bit, then we expect for this to be 4 times 8. 1, 2, yeah. 1, 2, 3, 4, 6, 7, 8. Yeah, it's 8. All right, yeah, so that's 8. So 2 of these things, F and 0F, that's a byte. So 2 will go into 8 4 times. Yeah, so this is 4 bytes. And this is 2 bytes. Oh, okay. Yeah, that's why I was like, why does this have 4? That's not 4. Mask isn't 4 bytes. Yeah, it's 2 bytes. Because you take these in lumps of 2. F is only 4 bits. Yeah, F is only 4 bits. Each of these zeros represents 4 bits. Yeah, yep, because this is all hexadecimal. All right. Cool. Just gotta talk through that out loud. Okay. Well, back to what we were doing. I totally forgot. Did I close the window that I needed? I did. No, I didn't. Oh, yeah. So this would make this the fact that we have to do this Makes it a lot more complicated. Right? Makes it a lot more complicated. And possibly not useful. Because what we would have to do is we'd have to like process this until yeah, because we have, for example, in our test case here, we have 3 strings, right? And well, would we want to move 3 strings into SIMD? If we had to work on making sure all 3 strings were 16 byte aligned first, I don't think that would really be that useful. But we need to do that though. Because what we're doing is for each string, like for each letter, yeah. Yeah, because we would have like right here we have to load the thing into the register for SIMD. So and we would have to load each of these strings. Oh. So I don't think that would be useful. I don't think that would be useful. I wonder though if we had a data structure that we knew was 16 byte aligned and we copied the string to that. Then we're talking about doing a lot of copying, which may not be worth it. Hmm. Because it's not just the beginning part, is it? Handle the last few bytes. Man, whoever wrote this knows a lot of stuff. Whoever wrote this knows a lot of stuff. I don't think we need... I think in order to do this, I would have to, like, do some more experimenting on my own. Hmm. Will only auto-vectorize loops when the iteration count is known ahead of the loop. Oh. Man, I need to, like, study this and understand this. But I think auto-vectorized loops. I wonder if that's why... Yesterday when we were looking at this, when we were looking at, like, some of these, we were, like, looking at this one, it's like my submitted code was up here, right? And, like, what's going on with someone, like, right there? It's like, what could be slower? The code is largely the same. And I was thinking, well, maybe it's because each time through the loop we have to calculate this size. So I'm wondering if, like, the key to being faster is the fact that the loops can be, according to that post we were just looking at, these and we are using cling because that was just like something we looked at the beginning of this. Like, these can be auto-vectorized because we pre-calculated the length, the iteration length. We knew the iteration count ahead of the loop. He's even kind of talking about that. So, like, from doing string length first. So, like, don't calculate the length of the string here, calculate it there. Which is kind of the equivalent to what we were just talking about. So I wonder... I would be satisfied if I could, like, look at this and understand, like, yes, it got... the loop got vectorized. Oh, well, this one it didn't because... Ooh, okay, so... We took that out. It's compiling. Okay. So can we... Let's see if I control Z. I've gone silent because I'm just reading. I don't, I don't know enough to talk out loud while I do this. Hmm. Hmm. If we turn off the optimization, if we turn off optimization, we can see it. If we turn off the optimization, we can see that at this point at 23, we can see this call to size, right? So we kind of like, if there were no compiler options, then we would be kind of suspicious of this, just merely having to call this function every loop through. But I wonder if we add, I wonder if we take off the -1 if it still. Yeah, it still looks like it calls that function. All right, but we know that it is using this compiler flag. That's probably not the right one. I did 0 2. All right, now we can see it got it got rid of that call, even if I have the -1. Like, yeah. Question is, is like, where is that? Like, if I could look at this and be like, okay, I can see that it's not calling that function anymore with our optimization compiler flag. We can see that it's not calling that function anymore. It's like, where is the value? Where is the value? But maybe we can figure it out. So, what is JB? Oh, wow, man. Compiler Explorer is just cool. Checks the state of one or more status flags. Performs a jump to the target. So what it's saying is if the condition is met, it's going to jump to label 17, which is right here. Right, which is this loop here, right? It seems